These technologies have the potential to provide clean and affordable energy to the entire world. Founded on principles of scientific integrity, innovation, and humanism, ENG8 is developing catalyzed nuclear fusion technologies that deliver clean, low-cost energy. Their flagship product, EnergiCell, is a one-of-a-kind generator capable of producing more energy than it consumes, with zero harmful emissions. ENG8's mission goes beyond a technological breakthrough. It's a real contribution to building a world where energy is accessible to all and serves sustainable development. This is especially critical in the face of global climate change and the escalating energy crisis. At COP29, the UN's largest climate summit, where Alatra organization played an active role, one of the key goals was the transition to clean and affordable energy. In this context, innovations like EnergiCell are both timely and urgently needed. In this interview, Haslen Back, ENG8's Director of Development, tells us about the scientific foundation and unique advantages of EnergiCell, as well as plans to scale up and bring the technology to market in the near future.
Hello, dear viewers. Thank you very much for being with us today on our platform, and we are very honored to guest our esteemed guest, which is Haslen Back, BDO of ENG8 company. And hello, Haslen.
Hi, thank you very much for having me on your show. Thank you.
Thank you very much as well. So please introduce yourself to our public and maybe tell us how you got involved into this kind of research area and what led you down this path.
Well, I've been approximately 25 or 26 years helping companies commercialize their technology, and went from assisting companies commercialize technology to actually partnering with companies, owning technology. So for 26 years, started off in material science business. Then we slowly moved through into systems engineering. And then in 2017, we saw a fascinating interview with a professor called Vladimir Leonov, who had had a book published by a Cambridge scientific publishing house called The Theory of Superunification. And in The Theory of Superunification, he really explained Einstein's theory of relativity and quantum mechanics. And this, from 2010 onwards, he tried to persuade certain large scientific bodies, organizations, that his theory of superunification was a great way of explaining how new processes could be achieved on Earth. And when we met with him, he showed us that he had a number of devices that his theory could enable. He'd actually been a theoretical physicist and a nuclear engineer, and he'd really run up against a brick wall trying to explain to various different scientific bodies that this technology that his theory was actually correct. So to prove it, he went and rented a laboratory, moved to a remote town and in the countryside, and with his engineers, he built some devices, one of them being a small sunshine, a plasma ball inside water. And when we first saw it in 2017, we thought this is quite amazing, because when you boil water, it's very accurately known how much energy is required to boil, for example, a kilogram or liter of water. And he had actually boiled a kilogram of water for what appeared to be less energy than you would normally use. So at that stage, we signed a partnering agreement with him to assist in investing in that technology. And then over a period of time, up until, I guess it was February 2022, we then ended up acquiring the majority of that company, in fact, the whole of that company that actually had that technology in it. So that's how we got into this technology. We didn't even know it was called low energy nuclear reactions or cold fusion at that stage. We just thought we'd stumbled on something really unique, which we had done. But it was interesting. It was part of a wider scientific effort that's been going on for at least 30 years.
Right. Cool. Thank you very much.
Yeah, thank you very much. And a pretty interesting story that you were telling us. The second question will be, how does your generator really work? So what are the principles on which it operates? And if so, why it is better than our current methods of energy production?
I can answer that in a historical sense, that man has approximately used fire for 1 to 1.5 million years in a controlled manner to cook food, to heat their caves, etc. I think man has only known for a couple of hundred years the exact chemical processes behind fire. So man learned how to use it, man learned how to control it, man had all sorts of things. But the area of LENR is a contentious area amongst physicists. And there are many physical theories around, and almost as many physical theories around as there are forms of LENR. But I can explain one thing is a very good example. When you look at the sun and you see that the sun surface is protons, hydrogen protons, and the sun's surface is approximately 6,000 degrees centigrade. Well, 6,000 degrees centigrade, millions of miles away from us, wouldn't create much heating on planet Earth. However, when you look away from the sun to the solar corona, which is millions of miles away from the sun, then you'll find the heat source. It's millions of degrees centigrade, millions of miles away from the sun. So why is this? So the hot physicists, the hot fusion physicists like at ITAR and many hot fusion companies in the world, believe that the physics of what's happening in the sun is heating the sun. But the evidence doesn't appear to be quite so clear. When the evidence shows that millions of miles away from the sun, it's being heated up. And as the sun is passing, as the sun is a huge gravitational field is flying around the galaxy, it's dragging in huge amounts of dust to fire the nuclear fire of which it is. So we believe that fission and fusion, but mainly fission, is the process that's happening. So as the dust is being sucked into or gravitationally pulled into the sun, it's going through this huge plasma zone. And in this plasma zone, it's fissioning down into the solar surface. And in our LENR reactors, we can also see both fission and fusion happening at the same time. So why are we different? Well, we've taken a different approach to physics. We've created a different set of devices to create what we call catalyzed fusion or low energy nuclear reactions. And we've tried to simplify the process as possible to make the energy as affordable as possible from the reactors.
Very cool. Thank you very much for your explanation. So another question would be, is your generator suitable for, let's say, different use cases, for example, from household requirements up to the industrial scale, or what can you tell us about that?
Yes, I'll finish answering the previous question, which is slightly to do with the physics. So in nature, you see lightning, you see the aurora, the northern lights or the southern lights, these huge plasma fields around the Earth. And it's been shown recently that they're transmuting lots of materials in those areas. Also, we can see that in our reactors, we create like there is lightning in nature, fork lightning or ball lightning. These are huge quantities, 10 to the 26 plus concentrations of electrons. Now, conventional physics says that electrons should repel each other, when we can see in nature with our own eyes that is not always true. And in our reactors, we create very strong concentrations of electrons. And what happens is any atoms that come into contact with these condensed plasmoids, as they're called them, are pulled apart, which means the Coulomb barrier can then be minimized to almost nothing. So the atomic nuclei can then react. They can split or they can fuse together. The most important thing is when these conditions occur, you do not get harmful alpha, beta, or gamma radiation being produced, all the typical products you see in standard nuclear reactions, fission or fusion reactions. So when it comes to scaling, the first thing you want to do is ask, is it safe? And we've had independent inspectors in our laboratories showing that there is no change in background radiation around our unshielded reactors. Now, so they're safe, basically. They meet all the European Union emission requirements. In fact, even electrically, they emit, I think, only 5% of what your telephone does. So it's huge. It's hugely safe. And then what we can do is we can scale them, and we can either make bigger ones, smaller ones, or we can put lots together. So what we've been doing is on this wall over here, over there, that wall, we've been basically developing a 100 kilowatt device that is actually being assembled behind me there. And this 100 kilowatt device is approximately the size of a standard Euro pallet, 1.2 meters, 1 meter, 1 meter, and it can put out 100 kilowatts of either heat, electricity, or heat and electricity. And you put them together in like a standard 6 meter shipping container. It's like 2.5 megawatts. And you can put them together in a 40-foot, 12-meter container, and you've got 5 megawatts on site. So we can either create small units for houses, which we have, smaller units like this one here, for example. So a smaller unit can basically power your house or power your car, or you could put different units together. And this one, for example, is fueled by hydrogen. And if you put hydrogen in it, now a conventional fuel cell, not an energy cell, a conventional fuel cell is working in a chemical process. So the energy release mechanism is, say, for example, a unit of 1. Nuclear energy mechanisms can be 1 million times more intensive than chemical reactions. So, for example, you might add a gram of hydrogen, and that might keep this unit running, producing, say, half a kilowatt for years and years and years on end. So very efficient. We've also got another smaller one that, for example, is a bit big because it's a scientific prototype, but it would be about that big, and it could easily fit inside the battery space in a laptop, and that could power a laptop in the future. And we've got smaller ones. So that sort of size there would easily be able to fit in the battery space of your phone and power your phone. So LENR reactions happen in a myriad of ways, different ways. We have 5 different ways of creating LENR reactions within this laboratory. And we can produce everything from very small amounts of electricity, very high density, through to large commercial scale power plants. And at the moment, we're focusing on just supplying our local area. We're based in Portugal. So we're looking at basically in this year, having our 100 kilowatt module tested and reliable. Then next year, 1 megawatt of them deployed. The year after that, 10 megawatts of them being deployed. The year after that, 100 megawatts being deployed. So we're then increasing our production, and then we'll be able to license other companies to use this very safe, very low-cost energy technology.
Well, really great. Sounds very inspiring what you're talking about. It's very interesting. But how do you think these types of new technology can change, our relationship to energy consumption, and how they can affect the society on a large scale? And if they will really come to the market, how do you envision those kind of changes to the society?
Well, I'm not an economist, but everything we do is based on a unit of energy, effectively. And it's been growing ever since the Industrial Revolution. The price of energy has been going up as we require more and more energy. And the cost of producing that energy, either it's digging holes for coal, or it's drilling deeper for oil, or creating solar power or wind power, we've still got an increase. We've got a dramatic increase in the energy requirement on the planet as everybody wants a healthier, more active, more warmer or cooler environment to live in and to work in and play in. And now imagine our cost of production of energy is probably 5 times that of coal or gas, 5 times less, which means that it will drive a huge requirement for energy, I imagine, on the planet, because you've already got AI coming in as well, requiring huge amounts of energy. But the beauty of this is it's not producing any pollution. We're not using any rare earth metals. We're using existing production lines or production processes for the components that we're using. So if you imagine, I think 40% of India and Africa still cook on wood or organic dung fires, for example, and that leads to huge amounts of health problems all throughout the developing world. Not only that, they are also cutting down swathes of forests for basically fueling their fires to cook on. Now you'll be able to give somebody a unit that's not expensive. It'll be small, compact. They can use it, and they don't have to go out and cut wood down. They don't have to burn cow dung or camel dung inside their houses or huts or tents. They can actually have a pure clean energy tech cell producing pure clean energy in their environment. So it should have huge health benefits and environmental benefits for the planet.
That's great. That's great. And actually, this example you just gave gives me the perfect segue into the next question, which is, so will the production be, let's say, the distribution would it start specifically in some countries, in some places, or I don't know, what can you tell us about that?
There's two issues here. There's the altruistic aim and there is the commercial aim. So to try and balance the left hand and the right hand, we have to first of all satisfy our investors who are investing in our company. So we need to make sure we've got the system really working stably, reliably, manufacture cost effectively, and very well patented. So we've got 2 patent families out around the world at the moment. We would like to get another 3 or 4 of those granted. So within the next 2 or 3 years, we aim to not only have a good, stable, reliable power plant in production providing commercial energy starting the end of this year, but also at least 5 of our patent families granted in most key countries. Then what we plan to do is to go into countries that are less economically developed, India, for example, many parts of Africa, many parts of Asia, many parts of Central America, for example, and be able to set up manufacturing either in the country or in the region. But we suggest in country, because then a country can regain its energy sovereignty. So when a country has its energy sovereignty, then it's less likely to go and invade another country for its energy supplies. So hopefully we'll be able to bring a lot of peace and harmony because of this business model. We intend to roll out to our commercial customers, say, for example, in Europe, in the United States, Canada, or North America, China, and in those countries, Japan, etc., in the big industrialized countries, which only account for like 1/3 of the world's population, we can make a very good return for our investors. 2/3 of the world population lives in 2/3 of the world countries, and what we'll be able to do is we'll be able to provide a cost plus model in those countries. So we're not making a profit, we're not extracting any money from those countries, and we can reinvest that money in the countries for socio and economic development.
Okay, so it means that from a technical point of view, you would consider your company ENG8 at what stage? You're ready for the production, still there is some R&D work to be done, or already fundraising? What is the phase of the company you are in?
So give you a bit of history. We've semi-acquired technologies that were from previous scientific teams, and we've brought those scientific teams into the company. So they'd all been working for 15 to 30 years before we engaged with them, and we engaged with them the first team 7 years ago. So a minimum of 1/4 of a century of development has gone into each of these different technologies that are in our office, in our laboratory. So we have 3 laboratories. Each laboratory is focusing on a specific EnergiCell technology. We're in the laboratory in Portugal focusing more on the commercialization. So in the last 7 years, we've gone from sort of TRL2 to TRL4 technology readiness levels. This year, we intend to go to 5 or 6, and next year 7. What does that mean? It means next year we're in commercial supply of energy to our customers. So that's the pathway, and we've gone through so much learning to do and so much experimentation, and the technology is really ripe for now putting into production. So next year we'll see production starting in Portugal, small quantities to start with, as I mentioned, 1 megawatt next year, 10 megawatts the year after, 100 megawatts the year after, and then in 5 years we've got a customer just up the road that needs 1 gigawatt. So a huge amount up the road. So within 3 to 5 years, we will be basically supplying 1 gigawatt, but we'll also be licensing other companies to use this technology as well as increasing production in other countries.
Great. Thank you very much. And since you already touched upon the subject of, let's say, environmental problems and the impact that your technology could have on them, would you kind of expand and maybe elaborate on let's say, the ways in which the ENG8 device can help to basically combat the climate crisis, which is, let's say, very widespread right now and a hot topic?
Yeah, we were meeting with the chief technology officer of a company called the UK National Grid PLC. They manage the gas grid and they manage the electrical grid. So they've been around for over 100 years. Previously as a state company, now they're a public company in UK, and they manage the electricity grid on the eastern seaboard of America and other grids in Europe. So they are a big infrastructural company. And they said to us, like, we were demonstrating to them a 0.5 to 1 megawatt energy cell. And they said, what are you doing? And I said, well, we're trying to gear up for commercial energy sales electricity. And they go, don't bother. Because they said, look, the reason we're saying don't bother is because at peak times, the electrical grid is full, completely full. We can't take any more capacity. And to put a new high voltage line into a country, because of planning permissions and specialist engineering, everything else, is about 15 years. So they said, what we really need is you to and we know how to decarbonize electricity, wind, solar, batteries, nuclear energy, etc. There are all solutions there for decarbonizing. But there's 80% of the energy that the European Union uses is not electricity. It's heat, or heating fuels and transport fuels. Heating fuels are gas, transport fuels are generally liquid. How do we actually decarbonize a society when actually it all comes from oil and gas? And they said the best thing you can do is really focus on these major areas. So from a heating point of view, we provide high temperature gas, high temperature air. So that's for heating houses, spaces, factories, and industrial processes. We can create high temperature steam. So we can do two things with that. That's very, very good for industrial processes. And it's very good for also driving a steam engine. So we can do heat and we can do drive electricity, power ourselves. Now, how do you actually repower the existing transport fleet all around the world? And the solution is not a new one. People have been burning a gas called ionized water. It's called HHO, or Brown's gas, in engines for decades. Normally, they burn a bit of HHO to make their petrol or diesel go further. But there was a couple of times there have been people producing HHO to power cars. So you just put it in your engine. The beautiful thing about HHO is you can actually run a car, diesel engine, petrol engine, a diesel generator. You can run it on HHO. When it burns the HHO gas, hydrogen, oxygen, it then condenses produces water. The water vapors recondense. We put it through an energy cell. We put it back through the engine, and you can keep going around and around and around, almost ad infinitum doing that. So using this technology, you can tackle 40% of the world's emissions, which is transport fuels. You can tackle the other 40% of the world's emissions, which is is gas, industrial gases or heating gases or cooking gases. And that leaves the electrical supply. If in this device behind us, we can put hydrogen through one of these energy cells, these reactors. And by putting hydrogen through, you produce almost pure electricity coming out. And that, say, for example, a gram of hydrogen can produce megawatts of electricity, whereas a gram of hydrogen can produce a few joules of energy normally. But in a nuclear process, you can extract a lot more energy from hydrogen. So we can also tackle the electrical issues. So the advantage is that it's low cost and it doesn't need a big supply chain. So when you look at hot fusion, for example, it requires tokamaks to be designed, engineered, and built. And they're hugely expensive. There's no production process for tokamaks. Where do you get the magnets from to power tokamaks? There's no fuel from them because you generally need tritium to power the hot fusion reactors. And they're immensely expensive to build them, to operate. Here, everything we do is designed and basically ordered from companies that are powering the car industry. So the car industry is the biggest supply chain on the planet. Generally, we're using everything out of a car supply chain. We don't need anything new.
Okay, sounds really impressive and revolutionary, actually, because it's gonna be, I think, a great revolution. And one thing that come to my mind: how do you see let's say the future reaction of this huge big oil and gas company compared to this your invention? Because of course it's a big step change, it's a revolution. So how do you see the reaction? And also to combine this question, did you see around your company enough interest or enough big players that are ready to step in and to help your wonderful technology to go through the through the society and through the market?
Well, I'll try and illustrate that as an example. I think it's Southeast Asia, you've got macaque monkeys, and they live on different islands. And when a macaque monkey group on one island, which is maybe 2 hours swimming from another island, so it's pretty much they can't swim for 2 hours through shark-infested water. When one macaque group learns how to use a tool, another macaque group learns how to use the same tool on a different island. And so there's a thing where they said it's when you've got a critical mass of companies, it can spread through the consciousness of, let's say, our society, human consciousness, and it can basically start sprouting up in different places like a tree distributing seeds. And in Japan, you've got a company called Clean Planet, Miura. They have an LENR technology there, which is going into production for industrial heat. You've got 2 companies in North America, Brilliant Light Power and Brilliant Energy. They have LENR type reactors. A company, Orient Energy in Canada. In Italy, you've got Prometheus and you've got Leonardo in Italy. So all over the planet, there are these little companies springing up now. Now, if it was just us, I'd be very concerned because we could be like, removed by very powerful interests. But these interests are springing up all over the world now, and they're very well funded companies. There are in America, one of the companies there is valued at over $500 million. The Japanese is at over $1 billion at the moment. So they're getting serious investment going into those companies, getting real values, getting big teams behind them. So I think to answer your question, the cat's out the bag in that sense. The technology is out there. There's an international society for condensed matter and nuclear sciences representing scientists all over the world in this space. There's an industrial association called LENR-IA that's based in the States. They're promoting the companies in this space. So there's a lot of really good interest in this space. And I think, safety maybe 10, 20 years ago may have been a major concern. I think there are so many companies coming up with new LENR reaction types at the moment. It's really a race to see who can develop the technology fastest and deploy it as socially responsibly as possible.
Well, that's a very great explanation. And also, your answer kind of sparked the question that do you see all these other, let's say, inventors and, companies trying to innovate in this kind of sector, sparking competitions between yourself, which is also good for, let's say, the enhancement and the advancement of the technology itself, but also can there be maybe a synergy, a kind of consortium or something of that kind between these kind of new, developments and companies, or maybe is there already?
Well, there is. Within the International Society for Condensed Matter and Nuclear Sciences, which is hosting the International Cold Fusion Conference every 2 years. It's been sponsored by the Anthropocene Fund from America, Carl Page, and that is taking place in Japan at the end of May. It's a 4 or 5 day symposium in a large hotel conference facility, and you've got all the companies in the world basically in there, like sharing ideas and things, the scientists. And then you've got the companies themselves. We're hopefully coming together under the LENR Industrial Association, LENR. And as a company, we try and welcome new startups to the association ourselves. Like, for example, there's an Israeli startup called Metatron. And so they're named after an angel, I believe. And I've got a call with them tomorrow because they didn't even know about us. They didn't know there was a society that could assist them. So we're trying to create within a capitalist environment, because each company has raised money from different shareholders. Those shareholders want their own returns. But the beauty of that is that because you're in this space, there's competition. It's disseminated all around the world, so it's hard to get rid of as a new technology. And there will be a fight for market share. But the beauty of the fight for market share, with lots of companies taking part in it, is it will simply give the consumer a wider choice of where to buy LENR reactors in the future, where to buy the energy from them, and it will keep the prices, hopefully, keep driving those prices down. And imagine in 20 years' time, the first patent fields have basically expired. All the inventors in countries where patents really aren't upheld very much at all. Let's say a lot of parts of Africa, for example, which desperately need low-cost energy. Suddenly you'll be in an environment where everybody's basically copying and making these devices and creating low-cost energy to support their own local communities. No one can help them do that. Whereas if you own an oil well, yes, you can control the oil supply, but with such a readily available technology, it's going to be pretty impossible for anyone to control this tech.
Sounds great and inspiring, as I said a couple of times, because this is what is one of the the step change that we need in this moment all around the world. And in order to understand that, I would like to ask the question: what are if you have some concrete next steps? So for the people interested into this technology, and if you have some detail about that, when you foresee that we will have this on the market, and then people, for example, in Europe would be able to put it in their house.
Yes. There's two ways to answer that. Currently, it's approximately going to be the end of this year when we could have our first industrial power plant installed with a customer locally. And then, as I mentioned, we're going to go through scale up. But to go into the domestic market, there's many more regulations you need to go through in the domestic market than there is in the industrial market. Industrial market engineers, professional engineers sign off a product and go, it'll work. It goes into use. Go into the retail market in your own car, in your own house, etc. You've got all the warranty issues, you've got all the health and safety issues, you've got all maintenance, distribution channels, branding, everything else. So we've met with two of the world's largest companies regarding deployment for domestic users for heaters, for example. So for us to go into the domestic heater market would be absolutely senseless because it's all about distribution and repairs and maintenance. So for us, it'd be much more sensible in those situations to license it out. So I imagine in the next 5 years to 7 years, you'll start seeing products appearing in the retail market from well-known brands. It'll just be, they won't know what it is, but it'll have a GE stamp on it. It'll be not consuming any gas like they do at the moment. And there you are.
Thank you very much. That's great. So I would say, Haslen, thank you very much for being with us today and sharing this exciting news. Really, that has been really inspiring. And I will also, thank our viewers and maybe give you the chance, to plug in some links or website or whatever, maybe to our viewers which are interested to get to know more your technology.
Yeah, we have a very good, we have a fan base we call our investor base. So if you look at our website, ENG8 Energy, there's an investor tab there. We have over 100 private investors. Probably around 10% are actually currently working with the company that are invested and then decided to work for the company as consultants or full-time people. So yeah, we have a very nice, warm, open environment for people to come and see us and come and work with us and join in this energy revolution. So thank you very much for your time.
Thank you very much, Haslen. Really appreciated your time. It was a really great and inspiring interview, and we are looking forward to see your products on the market very soon.
Thank you very much. Thank you.
Thank you.